So I saw on Twitter this tweet from Santiago, and he says Pandas is the most popular data library, but it's slow. And he goes about saying that Fireducks is a good alternative because it's a lot faster, but also it has a fully compatible API. So I was curious. I looked at their website, then I looked at their benchmark, and then I saw that they're faster than the alternative, such as DuckDB, Polars, or Spark. So I decided to try it out. I looked at OpenFlights for a dataset because I want to learn about aircrafts and this industry. Here we have a database of airports, the location, and also the information about routes. And I thought maybe I can do some joints on this data and see if there's any meaningful impact on performance. So I created this open source repo, OpenFlights dashboard, to experiment with it. The main thing I want to say about this repo is if you want to run it on macOS, you need to use Docker and you need to set this Docker default platform Linux or AMD64 because Fireducks only works on Linux. So I deployed it on fly on a small machine here to try to play around with this data. So first thing to look into is this map where every point is an airport, and you can select software for a given country. The main reason we're here is to run this analysis where we're going to do some joints between the airports and the routes to be able to compute metrics such as the connectivity, total routes. And we can see that the most connected airport is Atlanta. And then we have Beijing here in China. So if you're interested, you can play around with this chart. We also have the distribution of distances and the degrees. At the bottom here, we have the execution time. The main computation comes from prepare route distances. It's about 1 second. And the next one is about 10 milliseconds, about 10 milliseconds. You can do other things. You can increase the number of, example here, you can change the sampling ratio to include more airports, but it's going to be slower and more laggy. That's why we set it to 10. And you can also select the countries you want to work with. For example, if I say Canada, I say United States, and I run the analysis. Now it's going to run the analysis, but only on these two countries. Also, it's going to be faster here. But the reason we're here is that we wanted to see what happens when you run it with Fireducks. So let's click on Fireducks. And with the same setting, with all of the countries, we run the analysis. And we'll see here that it effectively is way slower. And I did some checks in the code, and I saw it was particularly slow here on the apply function, where on every row of the data frame you do some computation. In this case, we compute the harvest sign distance, which based on long lat, you can deduce what is the distance on the map. Obviously, you could optimize this and pre-compute all of these distances offline, keep a distance matrix, and then use it when you need it online at inference. We can go down and you can see that it took 20 seconds, so almost 100 times slower than Pandas. And even for other computation, for example, the second one, which was about 10 milliseconds, now it's almost more than 10 times slower to do the network statistics. So the main takeaway of this video is don't get baited by these threads without doing the work yourself and testing it on your own data. So if you have a small data set, in this case the OpenFlight data was quite small, relatively speaking, and we got no performance gains from it. Actually, it was maybe 10 or 100 times slower to use Fireducks for this purpose. But if you have if you have hundreds of gigabytes, a billion rows, then maybe it's worth trying Fireducks. So that's it. So that was the point of the video. Thank you for watching. Bye-bye.